Hello everybody, welcome to another screencast for Research Skills 1. In this screencast I will explain how you do a correlation analysis in SPSS. The correlation we will be calculating will be between the score on the exam and the hours that you study. Before we start with calculating a correlation, it's always a good idea to inspect what the data looks like. So without much further ado, let's order up a scatter plot, like so. It's a simple scatter. The exam score we think is going to be related to the hours spent revising or studying. Press OK, and then we get data that looks like this. Well, already we can look at these data and see there's sort of a linear relationship present. Apparently, the more hours you spend revising, the higher your exam score will be. We're going to ask SPSS now to calculate a correlation coefficient for this in order to see how strong this relationship is. We're doing that by going to Analyze, and then Correlate, and then Bivariate. We will take these two variables, we add them together. Make sure we have the Pearson correlation coefficient selected and not the Spearman. Why? Because the Pearson is used for two variables that are ratio measurement level or interval measurement level, like here. And the Spearman is used when one or two of these variables are actually of ordinal measurement level. You will recognize this immediately in a scatter plot when these these dots, circles, are very close together. They're in like strata in a single line, in a single column like this, or in a single row like that. They are not scattered all over the place. They form a sort of like grid-like structure. In this case, that's not the case. So we can do a Pearson correlation. We will then press OK. These are our results. It's a bit of an anticlimax. It's the hardest thing you do in this course, but it's the smallest possible output you can get. You see a couple of things here. You see three numbers, the Pearson correlation coefficient over there, the sig two-tailed over there, and an n over there. What you need to remember here is the n is the amount of people who are actually in the analysis. So there are 20 people who have a score on hours spent revising, and the same 20 people have an exam score. So that's why you can compare them. That's why you can draw this graph. They are also present in this analysis. This value is actually the significance of the result. You can ignore this. It will return in Research Skills 3, where I will explain everything about it. At this point, you can ignore it. What it's all about, this analysis, is this correlation coefficient. You can see that it's 0.821. Given the guidelines that we've provided, this relation is a very strong relationship. So there's a very strong association between these two variables. The longer you study, the higher your exam grade is going to be. That is not saying the more you study causes a higher exam score. This is not a causal connection. There is no cause and effect present in this relationship. This is basically just an association. These two things change together, but the one thing does not influence the other thing directly. That's all what this number is saying. It's a correlation. Well, the other boxes, they're mirrored. So if you're looking at one row like this, you're looking at the other one as well. It's not really interesting. This is one because there's a very perfect correlation between exam score and itself. There's also a perfect correlation between hours spent revising and itself. And the inverse relationship here is the same as that one. So the relationship between this one and that one is 0.821, but the relationship between this one and that one is also 0.821. This is SPSS way of saying, yes, there is no causal effect. It's basically an association. It can be both ways. So based on this data, you can, with equal certainty, say that exam score is associated with hours spent revising, but hours spent revising is also associated with exam score. So no cause and effect, no direct relationship, only two things that change together. That's how you do a correlation. That's how you interpret a correlation. Make sure to check the guidelines for interpreting correlations in the lecture. Good luck with running your own correlation analysis.